got a good variety of problems here, so we're starting to review for the final exam where we're going to have all kinds of equations to solve. Starting with that first one, this one looks pretty crazy. We've got a lot of stuff going on here, but the important thing to notice when we circle the variables is that we have y's in different places, right? So we've got y's on both sides, and we've got more than one, so we're going to start by simplifying things. What's the first thing I want to do to simplify this? Distribute. So we'll distribute first. When we distribute the 5 on the left, 5 times 2y is 10y, and 5 times 1 is, okay, so we get 10y plus 5. We'll bring down our plus 3y there. And then on the other side, we distribute the 2. 2 times 10 is 20, and 2 times negative 2y is negative 4y. And we'll bring down our 14y. And was this 20 here positive or negative? That is positive, so we'll put a plus there and an equal sign on the line. All right, after I distribute, what am I going to do next? Combine like terms. All right, so on the left side, I see a 10y and a 3y that can combine and give us 13y. Can I combine this 5 with anything? No, so we'll just bring that down. On the other side, I see a 14y and a 4y. We combine those and get a 10 because this is a negative 4, right? So we get 10y, and again, this 20 here doesn't combine with anything, so we'll bring that down. All right, now it's simplified both sides. That's as much as I can simplify the left side. That's as much as I can simplify the right side. We still have y's on both sides, though, so what am I going to have to do next? Subtract the 10y. So we're trying to get rid of one of them. We'll get rid of the smaller one. So we're going to subtract 10y from both sides. And when we do that, those 10y's on the right side cancel, leaving 20. And on the left side, 13y minus 10y is 3y, and we've got our plus 5 there. Then what? Okay, subtract 5 from each side. Those 5's are going to cancel each other out, leaving 3y. And 20 minus 5 is 15. And then divide by 3. It's going to cancel out the 3 over here, leaves y. And 15 divided by 3 is? In this equation here, we have a square root. So setting up the equation, in addition to circling the variable and drawing the line of equality, what else do we want to do? What other reminder do we want to give ourselves? Box the square root. And why do we box the square root here? We want to get that square root by itself before we do anything else. We cannot get rid of this minus 2 or the times 3 that are inside of the square root as long as we have the square root. And we can't get rid of the square root as long as there's other stuff with it. So we need to get rid of everything that's outside of the box first. That's why we put a box around it. So what 2 things are outside of the box that we need to get rid of? The 4 and the 7. And which one of those 2 things should we get rid of first? 7. So we'll get rid of that by subtracting 7, right? So we subtract 7 on each side. 7's cancel. Everything else comes down. So we still have the 4, still have the square root. And inside the square root we have 3c minus 2. Make sure when you're writing your square roots that the stuff that's inside of the square root is still covered by the square root. Make sure it covers everything. If that minus 2 kind of drifts outside the square root, then it means something different. On the right side, 27 minus 7 is 20. Okay, we got rid of the 7, but we still have to get rid of the 4. And we're going to do that by dividing. Since that's a times 4 there, since it's right next to the square root, we get rid of it by dividing by 4. And those 4's are going to cancel. That leaves just the square root part now, right? So we've got the square root of 3c minus 2. And on the right side, 20 divided by 4 is 5. All right, now what? Can we get rid of the minus 2 now? No, it's tempting to do that. We want to get rid of that minus 2 eventually, but I can't do that as long as it's in the square root. So I have to get rid of the square root, and we're going to do that by squaring it. So we're going to square the left side. that'll get rid of the square root. But if I square the left side, I have to square the right side. All right, when I square the left side, that's going to cancel the square root out and leave what? 3c minus 2. And on the right side, that's easy. 5 squared is 5 times 5, which is 25. All right, now we just have a two-step equation. We have two things to get rid of to get that c by itself. Where are we going to start? Which one should we get rid of first?
2.
The minus 2 by adding 2. So we add 2 on each side, leaving 3c on the left, and 27 on the right. Then what? Divide by 3. That cancels the 3 out here, leaving c all by itself. That was our goal. And 27 divided by 3 is?
9.
This one's pretty similar to the last one, but instead of having a square root, we have a square. There is something different about this one when we get rid of the square, and we'll talk about that when we get there. But starting out, we're going to circle a variable, draw the line of equality, and box the square. Does that mean I should just put a box around the square here? No, I want to put a box around the square and what it's squaring, which is the whole parentheses. So we talked about this earlier. We need to be careful that we don't distribute that 3 because the e minus 1 is part of the square. So it's not really an e minus 1, but it's e minus 1 squared. And so distributing would be bad here. Instead of distributing, let's just get rid of the stuff that's outside of that box. So the two things we need to get rid of are
3 and 8.
the 3 and the 8. So which one should we start with?
8.
8. So we're going to get rid of the 8 by adding 8. And when we add 8 on each side, one side they're going to cancel, leaving 3 times the square. And on the other side, 67 plus 8 is? Okay, so we got rid of the 8. We still need to get rid of the 3 by doing what? Divide. Again, this is right next to the parentheses, so it's multiplication. And to get rid of multiplication, we divide. So divide by 3 on each side. 3's cancel. Leaves e minus 1 squared equals 25. All right, now we need to get rid of the square. We cannot get rid of the minus 1 yet because it's still in the square. So we need to get rid of that square first. And how do we get rid of a square? We take the square root. So we're going to take the square root here. That gets rid of the square. But since we took the square root on the left side, we have to do it on the right side. Whatever we do on one side, we have to do on the other. All right, so on the left side, the square and the square root cancel each other out. And that's going to leave just the e minus 1. On the right side, this is where this equation gets a little different. So we're looking for a number that multiplies by itself to get 25. There's two ways we can do that. What's one way? 5, right? 5 times 5 is 25. That's the obvious one. But the not so obvious one is going to be what? Negative 5. So 5 times 5 gives us 25. But also negative 5 times negative 5 gives us 25. So we're going to have to go over and write another equation. And the left side of that equation is going to be the same, e minus 1. But then the right side of that equation is going to be negative 5 instead of positive 5. So again, this equation right here is exactly the same as this equation here, except we have the other choice for the square root of 25. Now, the square root of 25 is really 5, positive 5. But this negative 5, when we take the square root in the equation, could be an answer also. So we need both. Now we're going to solve both. All right, starting with this one, let's just continue with the one we started with here. What do we do to get that e by itself? Add 1. That's a minus 1, so we're going to get rid of that by adding 1. So we add 1 to each side. When those 1's cancel, it leaves e equals 6. That's one choice. E could equal 6. Or we need to go over here and solve this one also to get our other answer for e. So we draw our line of equality, add 1 to each side there. And when the 1's cancel over here, that leaves e equals negative 4. So in this equation, e could equal 6 or e could equal negative 4. And we could check both of these answers. We've been practicing that a little bit. We could plug in the 6 for e in the original equation here and show that that works. And we could also plug in negative 4 into the equation here and simplify it and show that that also works. So these both are solutions to this equation. This one looks fun, doesn't it? So we're going to circle a variable, draw the line of equality, and I'm also going to box the square. Now, there's one thing that I can do in this problem before I get that square by itself. I don't need to box these two squares. Why do I not box this one or box this one? It doesn't have the variable in it, exactly. So I can get rid of those squares, but I can get rid of those squares by doing something other than taking the square root. I boxed this one because I'm going to want to get rid of that using the square root. So what could I do to get rid of the square here on the 8? Just simplify it, right? What is 8 squared? 64. So we're going to just, instead of 8 squared, we're going to write what 8 squared is, which is 64. On the other side, we can get rid of the square on the 6 by just simplifying that. What is 6 squared? 36. And can I do the same thing here with the g? Can I get rid of this square by simplifying it? No, because we don't know what g is yet. So we can't square a number if we don't know what it is, so we'll just bring down that g squared. Now I still need to get the square by itself. So what do I need to get rid of to get the square by itself? The 36. So how do I get rid of the 36? Subtract 36. So we're going to subtract 36 on each side. 36's cancel, leaving g squared on the right side. On the left side, what is 64 minus 36? 28. Okay. Now what? I need to get rid of the square on the g, right? So how do I get rid of a square? Take the square root. So I'm going to get rid of the square by taking the square root. And then if I take the square root on the right side, I have to take the square root on the left side. Right side's pretty easy. Square and square root cancel. That leaves g. Left side, 28's not a perfect square, is it? So what do we have to do? We're going to have to simplify it using a factor tree. We haven't done this in a while, have we? So we're going to go off to the side. We're going to write the square root of 28, and we're going to factor that. 28 is 4 times 7, and then 4 is 2 times 2. And what do I do with that? When we rewrite this, we're going to write the square root of 2 times 2 times 7. And then what? Circle pairs. What happens with those pairs? Goes on the outside, so we have 2 on the outside and 7 on the inside. Alright, so I'm going to get 2 square root of 7, because that's what I multiplied by itself to get 28. So 2 square root of 7 times 2 square root of 7 would be 28. And what do I do with that? Yeah, I need to put it on the left side of the equal sign, so I get 2 square root of 7 here. Now, we're not quite done. Besides boxing my answer here, when I take the square root of a number, I could get 2 square root of 7, but I could also get a different number. Anybody know what the other one would be? So when we took the square root of 25, we got either 5 or negative 5. So if we take the square root of 28, we're going to get 2 square root of 7 or negative 2 square root of 7. Now, we're not going to have to do anything else to get g by itself, so I'm just going to write it underneath here. But the answer also could be negative 2 square root of 7 equals g. So there are 2 possible answers here since the problem has a square on the variable. I will say that this type of equation right here, this is something that you're going to use next year to solve for something in triangles in geometry class. And in geometry, we're usually looking for like the length of something. And the length of something couldn't be negative. So next year in your geometry class, really this answer, the positive one, is the only one that matters in that problem. All right, but as far as our class goes, as far as algebra goes, it could be positive or it could be negative, so we're going to give both answers.